All right, we have a triangle. It has one side given, but we're missing the other two sides, which means we can't use Pythagorean theorem, at least not yet, because for Pythagorean theorem, you need two sides. So I have some options. I could use special right triangles. When we're told that there's a 45, 45, 90 triangle, then there are a couple special rules that you should know. And these only are true for 45, 45, 90 triangles. That is that both legs will be equal or congruent. The measurements of the legs will be congruent or equal. The hypotenuse will always equal leg times square root 2. So those are the formulas. If your teacher did not go over these with you, no big deal, because you can use trig as well. So if you know how to solve this using trig, go ahead. But let's use special right triangles just to get in the habit. So I'm going to take this. I know X and Y are the legs, so they're going to be the same. I just don't know what either of them are. So I'm going to take the hypotenuse equals leg times square root of 2 formula. And I know the hypotenuse is 4. The leg is X or Y, so I'm just going to say X times square root 2. I need X by itself, so I'm going to divide by square root 2 on both sides. I get X equals 4 over square root 2, which is not allowed. You're not supposed to have any kind of radical or square root on the denominator. So to rationalize the denominator, I'm going to say times square root of 2, top and bottom. And I'll bring that up here since we're running out of space. So I would end up with, since I'm multiplying square root of 2 on top and bottom, I'm going to have X times, or X equals 4 times square root of 2 over, now if you have square root of 2 times square root of 2, that's just 2, because it's square root of 2 squared. So I just have a 2 on the bottom, which is what we want. We do not want a radical on the bottom. Look if there's anything you can reduce with those numbers, which there is. So I'm going to have 2 square root 2 for my X value. You should be able to figure out the Y value.